All right, let's take a look at lesson 4.2 and 4.3, proving triangle congruence. So we've split this apart into two different lessons. The first lesson we're going to learn about the triangle congruences. In the second lesson, we're going to look at proving these using a two-column proof. So let's take a look here. First of our four triangle congruences. The first one is side-side-side congruence. So if we have two sides of one triangle congruent to two sides of another triangle, or excuse me, if three sides of a triangle are congruent to the three sides of another triangle, then the triangles are congruent by side, side, side. So look, if you look at this, we have three triangles in this triangle ABC, okay, congruent to three sides in the triangle DEF. So this is a side, side, and a side congruent to side, side, and side. So triangle ABC is congruent to triangle DEF. So if you remember back in the first lesson, we said that in order to prove triangles congruent, you had to know that all six corresponding parts are congruent. So these triangle congruences we're going to look at now is kind of a shortcut. So the first shortcut is the side, side, side congruence. Now before we get to the second one, we need to talk about the word included. In this lesson, we're going to use it two different ways, the included angle and included side. Included angle means it's an angle between two sides, two side lengths, and it's going to be two side lengths that would be congruent to one another. So in this case, AB and AC are both surrounding angle A. So we say that angle A is the included angle. Now if you look here, BA and AC, they both contain the letter A, which means A is the included angle. Now we're also going to look at an included side length, which means it's going to be surrounded by two angles. So side BC is the included side that's between angle B and angle C. All right, so let's look at the next one. Side angle side congruence. The abbreviation is going to be SAS. So if you have two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. So in this case, if we're looking at this, we have a side here, angle in between, side. So the angle should touch the two congruent sides. So this angle here touches this one, touches this side. And in the other triangle, it has to be the same way. This angle right here is the included angle. It touches the side and the side congruent. So therefore, this is true by angle or side angle side. So those are the first two. Now, this one here don't write down. So angle side side does not guarantee congruent triangles. So for instance here we have two triangles. They look completely different, but they're going to fall under the angle. They have the angle. We're going to have a side length that matches this side length over here, and then you have a side here that are congruent. So this is one example of how angle side side does not guarantee congruent triangles. It's not mathematically sound. So do not use ASS on any of your answers. So far we have side, 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 and side angle side. So now let's look at the next one that comes from lesson 4.3, angle side angle. So if we have two angles and an included side, so this side would be in between the two angles, it touches both angles. So in both of these triangles here we have two included sides touching two congruent angles. So therefore, we can prove our triangle's congruent. So if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. And then we have our last one. The last one's probably the most difficult because it's two angles and a non-included side, so it's not in the middle. And if the two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. So if this is all the picture gives us to go off of, and we look at it and we see we have an angle and a side that's not in between it. Okay, we have angle side here. Same non-included side, they're both across from angle 2. So therefore, that's enough to say that our triangles are congruent. So we have four ways: side, 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 side angle side, angle side angle, and angle angle side. So let's look at some examples here, determine whether triangles are congruent or not. So let's look at this first one here. Determine if the two triangles are congruent. If they are, state how you know they are. Okay, so let's look at this one here. There's always going to be some information that we're going to have to know on our own. For example, the reflexive property. The reflexive property is when two triangles share a common side. Okay, so by the reflexive property, this side is a part of both triangles, so we can say that this is a congruent side. So the given information is that this side is congruent to this side, and this angle is congruent to this angle. So we have an angle measure here, congruent to an angle measure over here. We have a side length congruent to a side length, and we have this side right here congruent to this itself. So the angle is not in between the two sides. We have a side here and we have a side right here. So this is ASS. And once again, we talked about earlier that ASS does not guarantee congruent triangles. So therefore, this one is going to be not congruent. And it's not congruent because it doesn't fall into one of our triangle congruences. So it either has to be all three sides, the angle in between the two sides that are congruent. We can have the angle that surrounds the side, so angle, side, angle, or two angles and a non-included side. So this one we have one angle, we have two sides, so the only one that would be side, angle, side, and the angle does not touch both sides, so it can't be congruent. So let's look at the second one. This one we have a side length congruent to a side length. We have another side length congruent to a side length, and by the reflexive property we recognize that this is congruent to itself. So we have a side, side, and sides, and the only one this can be would be SSS, side, side, side congruence. All right, so let's look at the next two. I want you to pause the video and then come back and check to see how you did. All right, so this one is going to be congruent by angle, side, angle. We have an angle measure here, angle measure here. So we have to have ASA in both triangles in order for this to be true. So by the reflexive properties, since this one is the same in both, we'll say that that's true. That's our side length. So we have an angle, side, and angle congruent to angle, side, and an angle. So that's going to be true by ASA. The side is in between the two angles. So it's got to be ASA in both triangles, not just one. So let's look at this one here. This one was also true by ASA. First of all, as you look at this picture, the first thing we recognize is that these two are vertical angles. We know vertical angles are congruent. So that gives us, we have an angle, they gave us a side, and now we found another angle, congruent to angle measure, side, and another angle. The side length touches both angles, connects to both angles, so therefore this is by ASA. All right, let's go to the next one. And you guys will try this one. Try E and F. Determine if they are congruent. If they are, write the reason why. If they're not, write not congruent. So pause the video, come back and check your answers when you're done. All right, let's look at this one. This one's got side, angle, and side. So most of you guys will stop here and say, oh yeah, this is congruent, it's in the right order. But if you look over here, we have an angle, a side, and then a side. The angle is not between the two sides like this one, so therefore this one is not congruent. So make sure you check both of your triangles to make sure that they both match up. And then let's look at part F. This is going to be true by side, angle, side. We have two sides, congruent to two sides. And then by vertical angles, we know that these two are congruent. So there's your angle measure. The angle is in between the two sides. So therefore, this is side, angle, side. So we were given two parts of information. Sometimes we had to find our third, or sometimes they gave us everything to determine whether our triangles are congruent or not. So now in this next part, they're going to give us what they want us to prove it by. And we need to know what was the given information that we should have had in the beginning, not what we knew. So we'll do the first one together. This one we want to prove by angle, side, angle. So we have an angle here. That means we need a side length. Well, UT is congruent to itself by the reflexive property, so that we know that. So that's not a piece of given information. The other part, would be I have an angle measure, I have a side, congruent to an angle measure and a side. I need one other angle, and that angle means I need to know that these two angles right here would be congruent because the side has to touch both angles. So the way we have to do is we have to name this angle. So we're going to say angle. We should know that angle DUT is congruent to angle SUT. So it has to match up corresponding parts. D goes with S, U goes with U, and T goes with T. All right, I want you guys to try part B. All right, so this one we're proving by side angle side, which means the angle measure needs to be in between the two congruent sides. Now we know that XV is congruent to itself by the reflection property, so there's one of our sides. We know they're both right angles, so therefore they're congruent. That's your angle measure, so that means we need one more side to surround this angle. This angle should touch both sides, so it touches this side over here, which means it's got to touch this side over here. So that's why we got to say that these two sides have to be congruent. These are the given information that we're missing. And we write it down here. If I started from V to W, I have to start with the right angle up here, which means I'm going from X to K. All right, let's try the next two. I want you guys to try part C and D. Pause the video, come back and check your answer when you're done. All right, so in this one here, we're proving it by side, side, side. We know that the QS is congruent to itself by the reflexive property. That means we should have been given that these two sides were congruent. Side RS, which is going to be congruent to side DQ. So remember to put them in corresponding parts. R and D go together, and S and Q go together. So RS is congruent to DQ. And this one over here, we're proving it by side angle side, which means we have an angle measure, and we need to surround it by two sides that are congruent. So vertical angles give us our angle. We get the two sides were first given to us. That means we should have been given side VW is congruent to side VM. And the last one. So this one here, if you look at it, we're looking to prove it by angle side angle. So we have an angle, we have a side, and that means it's got to be an angle that surrounds it, the other side, so it means it's got to be this angle right here. So if this is our angle measure here, this is our side length, we need to match it up with the other one, which means it's going to have to be angle T. So we would say that angle L is congruent to angle T, and that's the given information we would have needed. All right, so this concludes our first half of lesson 4.2 and 4.3. Tomorrow we'll look at, or in our next lesson, we will look at the proofs using side angle side, side side side, angle side angle, and angle angle side.